advisor was Dr. Brad Hines. So one of the projects I worked on last year was a solar energy project where we installed solar panels and provided shade to some of our organic grazing cows. So this solar system, we were lucky to get a grant from the Environment and Natural Resources Trust Fund to do this project. And we installed this 30 kilowatt solar system back in June 2018. Just some details about the solar system. As I mentioned, it's a 30 kilowatt system. The panels are mounted about 8 feet off the ground so that cows can't go up and rub against the solar panels. The total cost of the system was about $80,000, and it produces 4 megawatts of electricity every month. So next we will be kind of discussing some of our results of the project that I was a part of last summer.
We're standing underneath a solar panel, a 200 kilowatt solar array. This is a true collaboration between the West Central Research and Outreach Center and the University of Minnesota Morris. They came to us and wanted to know if we would be interested in putting a bigger solar array in one of our pastures. So of course, doing the research that we did, we agreed to it. And today we're standing in one of our pastures close to the University of Minnesota Morris campus, and we have about 80 dry cows and springing heifers. And it's a sunny day out today, and they're enjoying the shade underneath the solar panels that was the purpose, so we can produce energy and use shade for our cows.
So at the previous solar system, as I mentioned before, we conducted a study last summer, which essentially investigated using solar panels to provide shade for organic grazing cows. So in this study, we had 24 milking cows, and 12 cows had no access to any type of shade at all whatsoever, and 12 cows had access to the solar system and access to the shade cast by those solar panels. We looked at a variety of measurements such as respiration rates, body temperature, fly counts, drinking bouts, etc. And we did not find any differences in milk production between the two groups. We only had those cows on the study for about 28 days during the summer, so we probably didn't see any differences in milk production because it was such a short time frame. However, we did see a reduction in respiration rates between the cows that had shade and the cows that did not have shade. The cows that had shade had quite a bit lower respiration rates during the hot part of the day than the cows that had no shade. We also had these boluses in the reticulum of all 24 cows, and this is a SmaxTech bolus, and it records body temperature. So we were able to compare the two groups, and we found that the cows that had access to shade had about a 1 degree Fahrenheit lower body temperature than those cows that did not have access to any shade. So it was pretty clear to us that the cows that had access to shade were avoiding some of that heat stress during the hot parts of the day.
Today, I will be talking to you about our research using agrivoltaics to shade cows in a pastured dairy system. As we know, dairy producers today are facing many challenges, including demands for lower carbon footprints, increased human population, which in turn increases some dairy product demand, low milk prices, and climate change. So in a world where producers face many challenges, novel ideas on energy generation and utilization are needed. One such example may be using agrivoltaics. Agrivoltaics is the integration of solar photovoltaics, or PV, with agriculture. Large-scale PV systems compete with agriculture for land. However, PV and ag together may increase land efficiency by up to 75%. Think about during winter when land is unused by farmers. These producers could be generating revenue during this time while increasing the productivity of their land. Some research has shown that high night air and soil temperatures under solar PV may be decreased, which could lengthen the grain field period for those crops. Livestock may also utilize these solar PV shade structures to lower the intensity of heat stress. As we know, heat stress costs many millions of dollars per year in production losses and also has a number of other negative side effects on the cow, on reproduction, lameness, etc. There has been quite a bit of research done on heat abatement methods in freestall farms, such as fans, sprinklers, misters, but this research is really lacking in pasture-based dairies. So one of the largest reasons we wanted to do this study was to reduce heat stress in pastured dairy cows, and perhaps using agrivoltaics could help us in meeting this goal. We wanted to utilize an agrivoltaic system to investigate the effects of providing solar shade to pastured dairy cows. So we're using the shade cast by the solar PV system. We also wanted to investigate behavioral and biological effects of grazing cattle that had access to the 30 kilowatt shade compared to cows that did not have access to shade of any kind. The study was conducted at the West Central Research and Outreach Center during the summer of 2019. We used 24 crossbred organic cows, and those cows were randomly assigned to 4 replicated treatment groups with 6 cows per group. The treatments were either shade or no shade on pasture. We used an equal number of breed types and lactation numbers in each group, as well as an equal number of cows with a greater than 50% light colored coat, a greater than 50% dark colored coat, which is the cow in the bottom picture, and a mix of both light and dark, which is the cow in the top picture. And we conducted this study during 4 periods of the summer of 2019. Other observations that were recorded were fly counts per cow, fly avoidance behaviors, respiration rates, hygiene, hawk lesion, and locomotion scoring, shade use for the shade cows only, as well as milk, fat, and protein production from Bomatic Smart Dairy, and monthly DHI milk recording. We also utilized several technologies to record measurements that we would not be able to record. Otherwise, we put hobo pendant G loggers on the cow's legs to determine lying and standing behaviors, cow manager ear tag sensors to observe activity and rumination, as well as we administered SmaxTag boluses to each cow to record internal body temperature and activity. The data were analyzed using the PROC mixed as well as Glimix procedures of SAS. Our fixed effects were breed, treatment group, coat color, period, and parity. And our random effects were replicated group, date, and cow. So now that I have described a bit about the reasonings behind our study, as well as our methods, I'm going to be moving on into just a small portion of our results. These are the weather data from the West Central Research and Outreach Center's weather station during those 4 periods. The mean temperature stayed around 21 degrees Celsius during the whole study period. The high was 33.9 degrees Fahrenheit during period 1. Temperature humidity index is a measure of heat stress on dairy cows, and according to countless research done in the past, heat stress has been found to begin at a THI of 72. So if you look at all 4 periods, all of those periods had heat stress environments. These are our results for fly counts and respiration rates. There were no differences in fly counts for the shade and no shade cows during the morning or the afternoon. However, respiration rates were significantly lower during the afternoon in the shade cow treatments compared to the no shade treatments. So this indicates that shade cows were able to successfully reduce the severity of heat stress by utilizing those shade structures. These are our results for hygiene and milk production. The shade cows tended to have significantly higher scores for their bellies and lower legs, so they had dirtier bellies and lower legs, likely due to the cows urinating and defecating under the solar panels, and then standing up, laying down in that. And this area was their preferred loafing area within the paddock. And we also did not see any differences in milk production, fat percent, or protein. These are our results for our SmaxTech body temperature boluses from noon up through midnight. The shade cows had significantly lower body temperatures than the no shade cows. For daylight between milkings, which is essentially the same time frame, or closer to 8 a.m. to 4 p.m. Again, the shade cows had significantly lower body temperatures than the no shade cows. So this difference in body temperature may not seem like a large difference, but this change has been shown to have implications and is really what climate scientists have used to prove severe climatic conditions and even climate change occurring. This chart is showing the body temperatures of the shade and no shade cows every hour of the day during the study period, with body temperature on the y-axis and hour on the x-axis. The yellow are the no shade cows and black is the shade cows. So beginning at about 1 p.m. all the way through 11 p.m., the no shade cows had significantly higher body temperatures than the shade cows. This is almost a 0.5 degrees Celsius difference during the hottest part of the day. And this is really what we set out to show, and our results validate what we were expecting. That 0.5 degrees Celsius difference is really quite substantial and could possibly have even been a larger difference if these cows had access to the solar shade throughout the whole summer instead of just 4 short periods of the summer. In conclusion, the cows shaded by the solar PV system had reduced respiration rates and body temperatures during the hottest times of the day. Agrivoltaics may provide an acceptable method of heat abatement to cattle housed outdoors, so not just dairy cows on pasture, as was in this study, but perhaps even feedlot producers or heifer growers could look at agrivoltaics and incorporate that into their system to not only provide them revenue in the form of money, but higher production potentially, as well as a reduction in heat stress. As we know from prior studies, heat stress in beef cattle can really cause significant negative side effects, such as lower feed intake, less gain. Those cattle tend to have black coats, which increases solar radiation. So perhaps looking into agrivoltaics for feedlots could also be done. I also think that future research should study economics and long-term effects of the solar shade on milk, fat, and protein, body weight, body condition, and overall health and well-being of cows.